Hello, this is Numbers Lesson 3. In this I will discuss about even, odd and prime numbers. So let's say first what are the even numbers? Numbers that ends in means last digit is 0, 2, 4, 6 or 8. Number whose last digit is or ends in 0, 2, 4, 6 or 8 are called as even number. For example, 72 is a even number because it's end in 2. 240 is also even number. 468 is also an even number. 579 is not an even number because it does not end in 2, 4, 6 or 8 or 0. What are odd numbers? Odd numbers are numbers which ends in 1, 3, 5, 7 and 9. Any one of these. For example, 729 is an odd number, 523 is an odd number, 460 is not an odd number because it does not end in 1, 3, 5, 7 and 9. Now what are the prime numbers? Prime numbers. Natural numbers greater than 1 which are divisible by 1 and itself. Natural number which are divisible by 1 and itself are called as prime numbers. Natural number which are divisible by 1 and itself, greater than 1. Why we have not taken 1? Because 1 is neither prime nor composite number. We will start from 2. So natural numbers greater than 1 which are divisible by 1 and itself are called as prime number. For example, 2. 2 is the first prime number because it is divisible by 1 and 2. That is divisible by 1 and itself. Next prime number is 3. 3 is divisible by 1 and 3 is also divisible by 3. So 1 and itself. 5, 7, 11, 13 and so on. These are the prime numbers. The only even prime number is 2. All other prime numbers are odd. Only even prime number is 2. From 1 to 50, there are 15 prime numbers. From 1 to 50, there are 15 prime numbers. I'm just writing there are 2, 3, 5, 7, 11, 13, 17, 19, 23, 25, 29, 31, 37, 41, 43, 47. They are 15 prime numbers. You must know first 1 to 50 there are 15 prime numbers. 3, 3, 6, 3, 9, 3, 12 and 3, 15. There are 15 prime numbers from 1 to 50. And 1 to 100 there are 25 prime numbers from 1 to 100. The last one near to 100 is 97. There are bigger prime numbers than 97, but 97 is the prime number which is less than 100 and near to 100. Next is how to check whether a number is prime or not. 97 we know that it's a prime number, but when it comes to larger number, how to check whether the number is prime or not. For example, if I need to check 307 whether this number is prime or not, how I will check? There is method is that, for example, if I need to check n whether number n is prime or not, there are two steps. First step says that you have to take the approximate square root of n. Let's say this is equals to nearest equals to x, nearby equal to approximate value you need to calculate. Second step is that check the divisibility. I'm just writing divisibility of divisibility of n by all prime numbers less than equals to x, because every number is consist of prime factors. So we will check the only divisibility by all prime numbers less than equals to x. For example, 307 by one number. First step, I will calculate the approximate square root of 307. 307 approximate square root. I know that 18 square is, I'm just writing here, 18 square is 324, 17 square is 289, So this 307 lies in between 289 and 324. So I will take this approximate value is equals to 18. I will take a bit larger value. 307 approximate square root will be 18. Now second step, I will check the divisibility. I will check the divisibility, div divisibility of 307 by all prime numbers less than equals to 18. That is 2, 3, 5, 7, 11, 13 and 70. These are prime numbers less than 18. So I will check the divisibility of 307 by all of this. There is no shortcut method for this. The only way is this only to calculate the whether a number is prime or not. So 307, I will check divisibility one by one. This is not divisible by 2. 307 is not divisible by 2. Divisibility by 3 is also not divisible by 3. Same way 5. 7 4s is also not divisible by 7. 11 2s are 22. Remainder is 8. No, 11 also not divisible. 13 2s are 26. This is also not divisible by 13. 17 1s are 17 and is not divisible by also 17. So this 307 is not divisible by all prime numbers less than equals to 18. So this way, if it is not divisible, I can say that this number is a prime number. This number is a prime number. Next number I can take, let's say for example 407. Whether the number 407 is divisible by, or whether the 407 is prime number or not. Again, first step, take the approximate square root. 407 approximate square root is 21, because 20 square is 400, 21 square is 441. So I will take a bit larger number, that is 21. Now second step is to check the divisibility of 407. Divisibility of 407 by all prime numbers less than 21, that is 2, 3, 5, 7, 11, 13, 17 and 19. Now if you will check this number is divisible by 11. 407 is divisible by 11. If you will go and check one by one, I will tell you how to check in a faster manner in the upcoming lessons when I will discuss about the divisibility rules. But now you have to just simply divide by common method we know. So 407 is divisible by 11. 11 3s are 37. Remainder is 7. 11 7s are 77. This 407 is divisible by 11. It means that 407 is not a prime number. Not a prime number. Not prime. Because it is divisible by 11. 407 and 1. But by definition, prime number should be divisible by only 1 and itself. But 407 is divisible by 1, 407 as well as 11 as well as so many other numbers. So this is not a prime number. So that's the only way to check whether number is prime or not. Once you will learn about the divisibility rules, it will be quite easy for you to check whether a number is prime or not. Next are composite number. What are composite number? Composite number and natural numbers which are not prime. Natural numbers which are not prime are called as composite numbers. So 1 is neither prime nor composite. 1 is neither prime nor composite. What about others? Some will be prime, some will be composite. For example, 8 is a composite number. Any natural number which is not prime will be composite except 1. 15 is composite number. 18 is composite number. 37 is not a composite number. 49 is composite number because it's not a prime number. So that's the definition of composite number. What are co-prime numbers? Very important, co-prime numbers. Numbers whose SCF is 1. 2 or 3 number whose SCF is 1, highest common factor. I will discuss in detail about SCF in the upcoming lessons. But basic definition, no, highest common factor should be 1. For example, I am giving you some number that will be quite easy for you to check whether the numbers are co-prime or not. For example, if I am taking, let's say, 8 and 15. Is there any common factor in 8 and 15? Because 8 is 2 into 2 into 2. 15 is 3 into 5. There is no common factor in this. So their SCF is 1. They are co-prime. What about 9 and 15? 3 into 3 is 9. 3 into 5 is 15. They are not co-prime because their SCF is their SCF is 3. Highest common factor is 3. They are co-prime because their SCF is 1. What about 7 and 8? Are they co-prime? Yes, they are co-prime because there is no common. Very important. Any two consecutive numbers, natural numbers, any two consecutive natural numbers are always co-prime. Are always co-prime because there will no common in any two consecutive numbers. Are always co-prime. What about 6, 12 and 7? Are they co-prime? Yes, they are relatively co-prime. Relatively co-prime means that the total SCF is 1. They are relatively co-prime number. Even though 6 and 12 are not co-prime, total 6, 12 and 7, if you take all of these, they are relatively co-prime number because their combined SCF of all the three numbers is 1 because 7 is a prime number. So 7 will not have any common factor from 6 and 12. Although 6 and 12 are not co-prime. So this is the meaning of relatively co-prime. It means that all totality, if you take the numbers, their SCF should be 1. Let's say I'm giving some example on even and odd numbers. Let's say A and B are even natural numbers. C and D odd natural numbers. A and B even, C and D odd natural numbers. I'm giving you something you need to tell. A plus B. What would be A plus B? Think and then think of answer. A plus B. A is even, B is even. What about A and B? This will also be even because now in this case you don't need to cram any formula. In books there are formula even plus even is even plus odd is odd, but you don't have to cram any formula. Just assume many numbers. What is 2 plus 4? It will be 6. That is even. What about A plus C? Even plus odd, that is 2 plus 5. Answer would be 7. That is odd. What about C plus D? Odd plus odd. Answer would be even. Odd plus odd is also a even number. How even number? No need to cram anything. 3 plus 5 is always 8. 8 is even. What about A plus B into C? A and B is A plus B into C. A plus B is even into. Now this is even 2 plus 4, let's say, into 7. 2 plus 4, 6 into 7, answer is 42. This also be even number. So very important, even into something. Even number into anything. Any natural number. Even into any natural number, answer will always be even. Very important. What about A plus C cube into B minus D square? What about this? A plus C cube. Now don't need to cram. You know that A is an even number. So this is 2. C is an odd number. This is 1. B is even number 5. D is an odd number. Let's say 3. So 2 plus 1, 3 cube is 27 into B minus B 5 minus 3, 2 is 4. Answer is even. Again 5 minus 3, 2 square will be even. So even into something is always even. So this kind of question can come in exam where A, B and C, some even or odd numbers will be given to you and you need to tell what will be the product or sum or squares, etc. That was all about the even, odd and prime numbers. In next class I will continue with more lessons on numbers. Thank you.